question 10. And question 10, we want these populations to be the same. They're exponentials, and we're going to have to determine how we get rid of these exponentials and what we can do. So we want f of x to be equal to g of x. So my f of x is 16.8 e to the 0.0019 x power. So that is your f of x. And we're going to make that equal to our g of x, which is 13.3 e to the 0.0124 x power. So this is what we've got. Now, we want to get these equal to each other. Okay? And how are we going to do that? Well, we're going to have to do that by working with it as a logarithm. These can get kind of tricky when we look at them as a logarithm. If we take the log of both sides, we can do that, but we're going to have to do a lot of work ahead of time. Okay? We're going to have to break up these into separate logarithms because logarithms have some unique properties. How do we get rid of an e? Well, we get rid of an e by using the natural log ln. So I'm going to take the natural log of both sides. How is that going to work? And what is that going to force me to do? Well, let's write it out and see how we can solve this out. They do become a little bit tricky when we start working with them and breaking them up. So we now have the natural log of, and I'm going to use parentheses here, 16.8 e to the 0.0019 x power. And that equals the natural log of 13.3 e to the 0.0, make sure I got the right number of zeros here, 124 x power. And I got a pen if you need one. If that one doesn't work, I have one, so try that one. Yep, no problem. Okay, now how do logarithms work? Well, let's go back and remember our properties, because we need to eventually get this down to where we can use our calculator. We cannot use a calculator right here. We have to work with it. And logarithms have some very, very unique properties in that addition can become multiplication and vice versa. So when we work with logarithms, we have to go back to that first section when we discuss logarithms, which is 4.3, and we're going to look at these properties. So the first property we're going to do is we're going to look at this one. And this says that if I have multiplication, all right, I can split them up into addition. And then we're also going to be using our power rule, which says I can bring it down. Powers can come down. So we're going to have to break these up into separate logarithms. We're going to be using our calculator to work these out. So if I split this up, this is going to get split up into the natural log of 16.8 plus the natural log of e to the 0.0019x power. That equals now the natural log of 13.3 plus the natural log of e to the 0.0124x power. So that's what we've got. Okay, so we are here. Now, we can find these values in our calculator. And when we talk about this part here, this can come down, and the natural log, ln of e, is just 1. So that can come down. And same thing with this one. This is just 1 here, so that can come down. So now we're going to use our calculator, and let's see how far it says to go to. It says, assuming the trends continue, estimate what population will be when the populations are equal, and one around to the nearest million. Okay, so these are modeled in millions. So we're going to find x is going to be in millions. We're going to use our calculator, and if we want it to the nearest million, then we'll probably take it out 2 decimal places, maybe 3, and that should be more than enough. So let's use our calculator here. We're almost done. We want the natural log of, That's 16.8. And that is going to give us 2.82, we'll round 1. So 2.821. This part is just going to come down as 0.0019x, so that can come down. On the other side, we want the natural log now of that 13.3. Take the natural log first, and 13.3. And that gives you 2.588 if you round. Looks like 3 places should be more than enough. And that can cancel, so that comes down as a 0.0124x. So that's where we are so far. Now, what are we going to do from here? Solve it just like any other equation. So we'll move things around, and we'll solve it. So I'm going to move this 0.0124x over, and move that 2.821 over. See what we end up with here. All right, we'll do the left-hand side first. So, watch your decimals. It's very easy to make a mistake with these. We've got 0.0019 minus 0.0124. And so that gives you, on the left-hand side, a minus 0.0105x. On the right-hand side, put those together, and that's 2.588. We're going to take off that 2.821, and that gives you a minus 0.233. And we know we're on the right track because our x is going to be positive, which it should be. And so we'll now divide both sides by a minus 0.0105. And that now leaves me with x equaling, when I divide here, when you work it all the way out, that negative is going to make it positive. I just didn't keep it correctly in my calculator. Let me actually put it in here right. So 0.233. I'm going to divide that by 0.0105. Okay, and that looks like that's going to be 22.19, or about 22 million. So it looks like it should be about 22 million. That one just took a bit. You had to use properties of logarithms. Took us a bit to break it all down, bring things down, work with it. But that's going to be our answer on that. Okay. Any other questions out of 4.5? So we did 8 and we did 10. Any others? Okay. So, who needs the final exam schedule that I passed out a moment ago? Anyone need that? All right. So if you're going to be here on the day of the final, now make sure you read this. And again, when is our final? Our final is going to be, we normally meet 9:30 on Tuesday, Thursday, right? So our final, if you're going to be here on the day of the final, is going to be at 8 a.m. on Thursday, December 15th. And if you have to take your final early, make arrangements with me. But I think most of you will be here on the day of the final. Just so you know what we're going to be doing for this week is we're going to be looking at chapter 5, 5.1 and 5.2. Next week, we will start reviewing for our final exams. Next week, we are going to spend the class time working on our final exam, getting ready for that final. You've got a practice one we'll be going over. We've got the take-home one for you to work out on your own. And then you've got your final exam on that Thursday, December 15th. This is going to be the last homework packet that you were going to be doing. So this will be the last one. So this will be the last homework packet. So I'm going to pass out the last one here. And we'll get started. Getting close to the end. Most of you are doing very, very well. You don't have a lot of time left. This will be your last homework packet. And most students do very, very well in the final. We are going to spend a lot of time going over the final and getting you ready for the final. So I know the final is worth a lot of points, but students always do better on the final than any other exam because we spend a lot of time just going over that final and making sure that you know how to answer all the questions. So students generally do much, much better on that final than any other exam in the course. It does cover a little bit of everything, and you probably already have that practice final. If not, I'll make sure you get it on Thursday, so we'll make sure on Thursday that everybody has that practice final, take-home final. Let's go ahead now and look at 5.1 and 5.2. And we're going to be talking about systems of equations. And this is actually, I think, quite a bit easier than the logarithm sections. What we're going to be looking at is what are called systems of equations. Now, you need the same number of equations as you have number of variables. We're only going to work with 2 equations to start with, 2 variables. Then we'll do 3 equations and 3 variables, but it can be extended out. And we solve them simultaneously, meaning we plug one equation into the other one, or we use what's called elimination. So we either use substitution to solve these, or we use elimination. On Thursday, we'll talk about some operations we can use with matrices. So on Thursday, we'll be using what's called Cramer's rule and the determinants to work out these as well. But we're going to be focusing today on just systems of equations with 2 variables, and then once we get 2 variables down, we'll move on to 3 variables. And what these are is their lines. So when I talk about systems of equations, it's basically just 2 lines that intersect at a point. So if I draw 2 lines like this, what do we know? We know these 2 lines touch at one point, and that's an ordered pair. X, Y. So that's what we're looking at. We're looking at 2 lines that cross somewhere, and we're going to be finding where they cross. And there's different methods that we can use to solve these. The first method we're going to look at is what's called substitution. And we substitute one variable into the other. And so I'm going to be picking questions from our textbook. And we'll begin on page 536. And we're going to begin with question number 8. And we're going to solve this with what's called substitution. And I'm going to show you different ways of solving these. And it really doesn't matter how you solve them, what technique you use. Sometimes one method might be easier than the others. So we're going to start with substitution. And that means we're going to substitute one variable in to the other one, solve it down, and get a solution. So this is a system because we have 2 variables, x and y, and we have 2 equations. And so what we're going to look at is we're going to look at these equations, and we're going to solve one of them for a variable, and we're going to plug that into the second equation. When I look at these, I need to figure out which one's going to be the easiest to work with. And it looks like the second equation. Why? Because the first equation I can solve, but I'm going to have to divide, because you've got the 3 and you've got the 4 in front of the variables. But on the second equation, I can easily solve this for x. So let's take the second equation and let's solve this for x. You can solve it for y. It doesn't matter. We're just going to solve it for one of the variables. And try to find the easiest way of doing this. You wouldn't want to use the first equation because I'm going to have to divide. And that's going to make fractions. If I use the second equation, there's no fractions. And that's what we want. We want to avoid the fractions as much as possible. So let's take our second equation and let's solve this for x. You can solve it for either variable, doesn't matter, but I can easily solve this for x. So we'll add that y over, and so now we get x equals now y plus 13. So this is part of it, and now we take this and we plug it into the first equation. So we solved the second one for x, and we're going to plug that in to the first equation. So we're going to take this, we're going to plug it in. So we've got 3 parentheses, okay, from our first one, plus 4y equals now our 4. And what's going to go inside our parentheses? Y plus 13. And we'll just simply distribute our 3 through. So that gives you 3y plus 39 plus 4y equals 4. Clean it up. So 3 and 4 makes it 7y plus 39 equals 4. We'll move that 39 over. And that gives you now 7y equals, we've got 4 minus that 39. And that gives you, watch your signs, a minus 35. We'll divide by our 7. And that gives you y now equaling, it looks like 35 divided by 7. That gives you a negative 5, doesn't it? Okay. Now, that is not the complete answer. That is only part of the answer. When we solve these out, we have to get both. We have to get both parts here. So we have half of it. Okay, we've got the y part. How do we get the x part? We plug it back in. So we know that this is our y part. So now we can take this and we can plug it into either equation. So now we're going to use y equals that negative 5 in either equation. Let's just put it in the second one. So we're going to use this in equation number 2. And if I put this in equation number 2, I have x minus y, so that's minus 5, that equals 13. Double negative here makes it positive, so x plus 5 equals 13. We'll move our 5 over. And now what do we have? Now we have x equals what? 8. And so what is the actual answer? Bless you. As an ordered pair. The answer as an ordered pair would be 8 comma what? Negative 5. That's it. And this is called substitution. I'm going to teach you several ways today of solving these. Substitution, elimination, and then we're going to look at Gauss-Jordan elimination as well. So there's different ways of solving these, but that's our answer. Okay. Find one, plug it in, get the other. So they're not that difficult to work with. Let's do one more with substitution, and then we'll talk about elimination. So let's try one more with substitution. How about we look at question 14? So same page, page 536, we're going to look at question 14. And these aren't really that difficult. It's just easy to make a mistake. It's so easy to accidentally add wrong or subtract. So you have to be very careful with your signs and just take your time. Question 14 is 4x plus 5y equals 7. And our second equation is 9y equals 31 plus 2x. And we're going to use substitution. Now, whatever method you use, whether it be substitution or elimination, you want to look at these and try to do it as easy as possible. Right? You want to avoid fractions. Sometimes they're inevitable. You want to avoid extra steps. Now, we are going to use substitution, so that means we're going to solve for one of the variables, and we're going to plug it into the other. We have our two equations. And when I look at my two equations and I look at my second equation, what do we notice? It's mostly solved for what variable? It's mostly solved for y, right? So we can do that. Now, we can do the first equation and solve it for x or y, and that's going to give us fractions. Second equation is also going to give us fractions. So fractions are inevitable in this case. So it looks like the second equation is almost solved for y. So let's finish it out and let's solve the second equation for y. So take the second equation and solve it for y. So we've got 9y equals, and I'm going to rewrite it as 2x plus 31. And we'll divide by our 9 everywhere. And now we've got y equaling 2/9 x plus 31 over 9. Fractions in this case are unavoidable. What are we going to do with this? We're going to take this equation. Now you have to use both. So we used our first equation, second equation here. We have to use our first. So we're going to find out what y was, and we're going to plug it into the first equation. We already used the second equation. So plug that into your first equation. And then we'll deal with the fractions in a moment. So plug this into the first equation. So we've got 4x plus 5 times 2/9 x plus 31/9. And that equals 7. So we plugged in, right, this into here. And now we should be able to finish it. We're down to one variable. That's what we have to do. We have to eliminate one of the variables to get it down to a single variable that we can just directly solve. So let's go ahead and work with this. We're going to distribute the 5 through, and then we'll clear the fractions. So that 5 is just a 5 over 1, so we just multiply our numerators. So we have 4x plus 5 times 2 makes it a 10/9 x. And then 31 times that 5. That's a 155 over 9. And that equals our 7. We've done a lot of these. What do we have in our denominator? We have a 9. So how do we clear our fractions? Multiply everything by a 1. 9. Clear all of those out, and we're on our way to solving. So go ahead and multiply through that 9. And 9 times 4, well, that's a 36. X there. 9's cancel, so that gives you a 10x. 9's cancel, plus 155. And 9 times 7, well, that looks like that's going to be a 63, doesn't it? Combine. So 36 and 10, that makes it a 46x. We'll move that 155 over. And if everything went correctly, we should end up with a whole number. So we've got 63 minus 155, and that gives you a negative 92. Divide by our 46, and x now comes out to be negative 2, doesn't it? Okay. So now we have half of it. We can't stop here. This is only part of our answer. What do we need to do to get the other part? Plug it back in. Now, does it matter which equation I plug it into? No. Try to plug it into the one that's the easiest. I would say the first equation looks pretty easy because I know my x is a negative 2. So it's going to be pretty easy to plug it into here. Plugging it into here would be more work. Okay, so let's just plug it into the first equation. So we've got our negative 2. We're going to plug that into our first equation. So plug that into your first equation. And so that is then 4 times a negative 2 plus 5y equals 7. And 4 times a negative 2, well, that's a negative 8. Plus 5y equals that 7. We'll add that 8 over. And we're almost finished here, because now we've got 5y equals 15. Divide by your 5, and y equals now what? Y equals now 3. So my answer has to be written as an ordered pair. So how do I write my answer? My answer is going to be minus 2, comma 3. So you put them together as an ordered pair because that's x and y. So that method is called substitution. Next, we're going to learn how to use elimination, which is easier, I think. And then we'll talk about some special equations where they have either no solution or an infinite number of solutions. Okay, so let's do a couple of elimination questions. Elimination is what you're normally going to use. Substitution is very rarely used. It's used if you haven't already solved for a variable. Normally, though, we use what's called elimination. So we're going to solve these with elimination. Okay, so let me grab a couple of these to solve with elimination. And let's look at question 20 on page 536. So 536. We're going to look here at question 20. And we're going to use what's called elimination. And I think it's quite a bit easier. Once in a while you do use substitution, but really not that often. Okay, so what we want to do here is we want to get these equations to where we can cancel out one of the variables by adding them together. And so we look at the variables and we look at them together as a whole. And we want to see, well, how can we get rid of them? And we're going to do that by multiplying. I can either eliminate the x or I can eliminate the y. Doesn't matter. They're both about the same level of difficulty here. how about I eliminate the x? So notice this one, well, this is 3x, right? And this is my first equation. What can I multiply the second equation so that I get that 3x? Well, it needs to be multiplied by 3. So I'm going to take my second equation, and I'm actually going to use a negative 3. Now, why am I going to use a negative 3? I'm going to use the 3, that makes it a 3x. I'm putting the negative here so they cancel out, because I'm going to be adding down. And when I add down, I want one of the variables to go away. So they need to be the same and opposite in signs. So this is a positive 3x. Well, I need a negative 3x. So I'm going to put the negative 3 there, and I'm going to distribute through. So the top equation stays the same. The top equation is still 3x minus y equals a minus 4. Make sure I copied it correctly. Yep, negative 4 there. And the second equation, when I distribute through, is going to be a minus 3x, right, when I distribute. Minus 3 times 3, that makes it a minus 9y. And minus 3 times 12, well, that's a minus 36, isn't it? Now, when I add down, what's going to happen? When I add down, look at these x's. Are they the same? Yes. So they're going to go away. And we are going to eliminate the x. And you can eliminate whatever variable is the easiest. So we're going to go ahead here and add down. So let's go ahead and add down. Now what happens to the 3x's? They cancel. And if I add down, I have a minus y and a minus 9y. That makes it a minus 10y. Minus 4 and a minus 36. Well, that makes it a minus 40. We divide by our negative 10, and look at what we now have. We have it as y equals a positive 4, right? Okay. Now, what do we need to do? We need to get the other one. You can either eliminate for the y, or you can take what you've got and plug it back in. Okay, so we've got the y equals 4. How do we get the x value? We just simply take it and do what? Plug it back in. Does it matter where it goes? Nope. Plug it in somewhere. Okay, so we're going to take that y equals 4. We're going to plug it in. So now we've got 3x minus 4 equals minus 4. Okay, we'll add that 4 to each side. That gives me now 3x equals 0. We'll divide by our 3. And now we have x equaling what? 0. So what's my final answer? 0, 4. And that's it. Usually we use elimination. You don't use a lot of substitution unless it's solved for a variable already. Let's try one more of these, and then we'll look at one where we have more variables. Let's look at one that has a fraction. Let's look at, how about question 30? Question 30. Question 30 is x plus 6 over 5 plus 2y minus x over 10 equals 1. And then the second equation is x plus 2 over 4 plus 3y plus 2 over 5 equals a minus 3. Now, again, we're going to solve this with elimination. And it has fractions, so why don't we begin by just getting rid of all the fractions? So we're going to do each one separately. So we're going to clear the fractions out of each equation. And then once all the fractions are cleared out, we'll see what we're left with. And then we'll use elimination from there. So let's let's first clear out all the fractions. So this one does have a few extra steps. So let's go ahead and rewrite this. And I'm going to work with each equation separately. So we're going to have to do both of them. So here's 1 and here's 2. So let's take our first equation and let's break it up. I'm going to break it up into separate pieces. This way it'll be easier to clear these fractions. So break this up into x over 5. So that's my first one. Plus 6 over 5. I'm just splitting it up. Plus 2y over 10 minus x over 10 equals 1. So I split everything up into separate individual fractions. Now, what do I use for my common denominator? What do we have? We have 5s and what? 5 and 10s. So, multiply everything by what? Can someone tell me? What would I multiply everything by? It looks like we're going to multiply it all by what? By 10, right? Okay, so multiply everything by 10. And 10 divided by 5? Well, 10 divided by 5 makes it a 2. So that's a 2x there, bless you. 10 divided by 5 is 2. Times 6 makes it 12. 10 divided by 10 is gone, so that's a 2y. 10s are gone there, minus x. And 10 times 1 is a 10. Clean it up. Get the x's and the y's on the left-hand side, and then we'll work with the second equation. So go ahead and clean this up. And I'm just going to write the x's first. We'll put the x's together and move that 12 over. So we've got 2x and a minus x. That leaves you with an x. I'm going to move the 12 over. And we've got a 2y, so that's there. And the 12 goes over, and that makes that now a negative 2. So that's what we've got so far. Now, we are going to have to go through and do the same process for the other one. So it is going to be a process to go through and clear out these fractions. But that's what we have to do. Make sure you're very, very careful with the signs. Make sure you don't make a mistake. It's so easy with these to make a mistake, to miss something, not clear out the fractions correctly. So you've got to make sure you're very, very careful when you work these out. And everything looks right so far. Just double checking and making sure that it all looks correct, because you really don't want to make a mistake. So that's the first equation. Now we're going to take the second equation, and we're going to work with it. So our second equation, split it up. Do the same process. The second equation is x plus 2. So we're going to write that as over 4. So we're going to write that as x plus 4 over 2 over 4. You could reduce that down to a half, but it doesn't matter. We're going to have to get rid of it anyways. So we've got 3y over 5 and 2 over 5. And that equals now our minus 3. So that is what we have there. So now we've got to work with this. So clearing out our fractions, we've got a 5 and a 4. That means we're going to have to use a 20. Distribute that 20 through. Be very, very careful with the signs when you work these out. It's so easy to make a mistake. So 20 divided by 4, that's a 5. 5 times x, that makes it a 5x. 20 divided by 4, that's a 5. 5 times 2 makes it a 10. Right? 20 divided by 4 is 5. Times 2 makes it 10. 20 divided by 5, that's a 4. 4 times 3 makes it a 12y. Okay. 20 divided by 5, that's a 4. 4 times 2 makes it an 8. And that equals now 20 times a negative 3. Make sure you multiply both sides. So that's a negative 60. Now we can combine and see what we're left with. So we're going to go ahead and put 10 and the 8 together. And so we have 5x plus 12y. 10 and 8 makes it an 18, and that equals a negative 60. We're almost finished here. Move that 18 over with subtraction. So now we've got 5x plus 12y equals now, we've got 60 plus 18, both negative, which that makes it a negative 78. So there is our second equation. Now what do? Now we've got our two equations. Now we're on the right track, so now we solve. Okay, so let's write up our two equations and solve them. So x plus 2y equals a negative 2, and 5x plus 12y equals a negative 78. So I need to solve this. Okay, so what am I going to do? It looks like when I go to solve this, and we're on question 30 here, make sure everything looks right. Yep, everything looks correct so far. It's so easy to make a mistake on these. You just have to clear out your fractions and work with them. Okay, so we're going to go ahead and solve these. So let's, either way we want to work it out, let's eliminate for the x. So if I want to eliminate for the x, I'm going to have to take the first equation, and I'm going to have to multiply it by a negative 5. So let's take our first equation, multiply it by negative 5. Because that's going to make it a negative 5x, a positive 5x, and they'll go away. So distribute through and rewrite it. So we are going to eliminate for x. So when I do that, that gives you a minus 5x minus 10y equals, negative and negative makes it a positive 10. Hopefully we solved this all correctly here. Hopefully we didn't make a mistake. I don't see anything so far. And then we have a 5x plus 12y equals that negative 78. So what are we now going to do? We're going to add these down, and we get 2y equals, when we add down here, we get a minus, it looks like 68. So we're adding down there. We're going to divide by our 2. And now we have y equaling a negative, when we divide through, 34, isn't it? That's going to come out to be a negative 34. So that should be correct. Yep, we did it all correct. Everything is right. It just took us a bit to get there. Now, once we have one of them, what do? We take that and plug it into something else. One of the equations. Doesn't matter where we plug it into. We've got one variable. We're almost done. I'm going to plug this into there. So I'm going to plug in that y equals a negative 34. And so that gives me 5x plus 12 times a negative 34 equals that negative 78. And we need 12 times a negative 34. That gives you a negative 408. So 5x plus a minus 408 equals that minus 78. I'm going to add that 408 over. And now we've got 5x equals, we've got 408, which is positive. Take away that 78. That gives you 330. Divide by our 5, and we now have our x, which our x is now what? 66. So that's our answer. It took us a minute to get there. I only gave you one of these to work out in your homework. There's just one of them. Question 4 is a lot easier. Question 4, you just multiply by 5 and you're done on both of them. Question 5 in your homework is just like this. Different numbers, but very, very similar. It's going to be done pretty much the exact same way. It just takes time to go through and work out. So what's my final answer as an ordered pair? Well, it's 66, comma, negative 34. And that is my final finished answer as an ordered pair. Not really difficult. It just takes time. And it's so easy to make a small sign error. So when you work these out, just take your time. That is what we've been using when we have just 2 variables. Okay, we're going to have to do the same process when we have 3 variables. However, when we have 3 variables, we have to eliminate multiple times. We have to eliminate one of the variables, get it down to 2, and then eliminate again, and then start plugging it back through. So when we look at 3 variables, this is where it takes a little bit of time, and you've got to be very, very careful with your signs. So let me get these written up here. Okay, so it's 4. Okay, so we're going to do a couple of these. Well, probably just one, because they take so much time to go through. And then we'll talk about systems that have no solution and a system that has an infinite number of solutions. And then we'll look at Gauss-Jordan, if we have time. So we're going to solve here. I will pick one of these from our textbook to look at. Let me try to find a pretty easy one. We'll start off with question 47. So this is on page 538, and we're going to look at question 47. And this is x plus y plus z equals 2, and 2x plus y minus z equals 5. And the last equation is x minus y plus z equals a negative 2. So, when we look at an equation, a system like this, this has 3 variables. Now, we need to figure out where to begin and what variable to eliminate. We look at the variables together and we see which one or ones look the easiest. I want to avoid multiplication as much as possible. So I wouldn't want to eliminate the x, because if I try to eliminate for x, I've got to multiply. This would by a negative 2, this would by negative 2. But look at the look at the y and look at the z. If I add here, that goes away, and this can get multiplied and go away from there. Same thing with the z. So we would want to avoid eliminating for the x because of the 2. So we're going to eliminate for either the y or the z. Doesn't matter. I'm going to go ahead and eliminate for the y. So pick a variable at the beginning, and we've got to eliminate. Now, we do this 2 at a time, and we have to use all 3 equations. So as we use them, we're going to check them off. So we have to use all 3. We have to pick them 2 at a time. So I'm going to pick 1 and, how about 1 and 3? Now, why am I going to use 1 and 3? Because we're eliminating for y, and look what happens if I just add these together. If I just add those together, what's going to happen to the y's right there? They're going to cancel, right? Okay, so 1 and 3. You've got x plus y plus z equals 2. That's 1. And 3 is x minus y plus z equals a minus 2. Now, if we add these together as they are, we're in luck because what's going to happen to the y's? They're going to cancel. So that is x plus, adding down, 2x, right? Because x and x makes it 2x. Z and z makes it a 2z. And 2 and a negative 2, well, that goes away, and that gives you then what? That gives you then 0. Mark them off as you've used them. So we have used 1, and we have used 3. Now, we have to use equation 2. We can either use 2 and 3 or 1 and 2. I would say use 2 and 3. Why? Because when I look at 2 and 3, what's going to happen with the y's when I just simply add them together? When I just simply add these together, they're going to do what? They're going to go away. So let's do that. Okay, we're going to use 2 and 3. And if I take 2 and 3, that uses equation 2, which is what we had to do. And when I take 2 and 3 and I put them together, well, that's 2x plus y minus z equals 5. And x minus y plus z equals a minus 2. So when I take those and I add them together, what's going to happen here? We're in luck, right? And we're really lucky because when I add them together, what happens? 2x and another x. Well, that makes it a 3x. The y's cancel. The z's cancel as well. So we're left now with 3x equals 3. Divide by our 3. And so x is now what? X is 1. So we're on the track of finishing it all. Now, once we've got the first piece, then we have to start working backwards. When I plug in a variable, I want to make sure that I only have one other variable. So I can't plug this x equals 1 back into any of the originals, because if I plugged in the 1, that would give you 2 variables left. And we don't want 2 variables. We want to get it down to 1 variable so I can get a solution. So where do we have 2 variables at? Right here. So work your way backwards. Plug it in there. So it doesn't matter where you plug it in, as long as you can get it down to 1 variable and get a solution. So plug it in. And that gives you, now when you plug that in, 2 times 1 plus 2z equals 0. So that's 2 plus 2z equals 0. Move the 2 over. So 2z then equals a negative 2. Divide by your 2, and we have another part. So now we've got z equaling negative 1, don't we? Okay, so what variable are we missing? We've got the x, and we've got the z. So we are missing the y, aren't we? So we've got to plug it back into some equation that has a y in it. That means we go back to the very original. And on our very original, doesn't matter which one we use. We plug it in to one of them. How about I just plug it into my first equation? So we know what x is, we know what z is, we can easily now get the y. So let's rewrite it and get the y. So we're going to plug it in. And so we've got, I'll write it up first. This is equation 1. We've got x plus y plus z equals 2. We're going to plug our values in. So we're going to plug in 1 plus y. We've got our z, which is a minus 1, and that equals 2. Well, that's easy enough. 1 and a negative 1, those go away. So y now equals what? 2. And so what's my answer? As an ordered triplet. And ordered triplets go x, y, and z. So as an ordered triplet, it looks like it would be 1, 2, and negative 1. So that's how we solve question 47. They take a little bit of time to go through, and a little bit of time to solve. Now we're going to talk about equations that have either an infinite number of solutions or no solutions. We'll do one that has no solution first. And I'm only going to give you ones that have 2 variables for these, because 3 variables is quite a bit more complicated. So we're going to look at some now that have no solutions. So let's look at one of these. How about we look at, I'm on page 537, we're going to look at question 32. And we've got 3x plus 2y equals 5. And we've got 6x plus 4y equals 8. And so I want you to solve this one. Now, this is going to be like a contradiction. It has no solution. And let's see why it has no solution. So the first thing we need to figure out is we need to figure out how we can clear out one of the variables. Doesn't matter which one we use. Either the x or the y, they're about the same. I would say take the first equation, and I'm going to eliminate for x. So can anyone tell me what I would use to eliminate for x in the first equation? I want to eliminate the x. So this one has a 3. This one needs a 6. Has a 6. So what do I need to multiply this first equation by to make it a 6 here? What would I use? Can anyone tell me? 3 times what makes it a 6? 3 times the 2, right? Now, do I want them to be the same signs? No. I want to make sure they are different. So we're going to multiply it by a negative 2. Why am I using a negative 2? That way we have a positive 6x and we have a negative 6x. That way they go away. So go ahead and multiply through. And so that is a minus 6x, a minus 4y, equals to a negative 2 times 5. Well, that is a negative 10. Now, the second equation stays the same. 6x plus 4y equals 8. We're going to add these together. Now, when I add these together, what's going to happen here? When I add them together, okay, the x's go away, right? The y's go away, so the left-hand side is 0, but what about the right-hand side? Minus 10 plus 8, well, that's a minus 2. Now, this is a false statement. It's a false statement because can 0 equal a negative 2? No, right? We cannot solve it and we cannot get an answer. So what this is this is false. Now, we call this inconsistent. So it's called inconsistent, and it has no solution. So it's inconsistent, and it has no solution because it's false. It's just like a contradiction. We just don't say contradiction, we say inconsistent. And what this would be was this would be 2 lines that never cross. They're parallel lines. Okay, they have the same slope, they're parallel. No solution because the variables go away. and the sides don't match up. They're different. That's when you have no solution. Now we'll look at one that gives you an infinite number of solutions. So 34. Same page, so page 537. We're going to look at question 34. And that is 3x plus y equals negative 2. And the other one is 9x plus 3y equals negative 6. Okay, so this one should now give us an infinite number of solutions, and let's see why. Eliminate one of the variables. Doesn't matter which one. I'm going to eliminate for the x. And if I want to eliminate for the x, what do I need to multiply the first equation by? Yep, negative 3. Make sure you distribute that through. Now we've got a minus 9x minus 3y equals negative and negative makes it a positive 6. Second equation is 9x plus 3y equals a negative 6. Add those together and we get 0 equals now 0, right? Because the sides are the same. If the sides are the same, then this is called dependent, right? It's just like an identity. So these are the same. And so this is like an identity. We call these equations dependent. We have an infinite number of solutions. And here's how we write our answer. How we write our final answer is we take one of the equations and solve it for y. So we want to take one of these equations and we want to go ahead and solve it for y. It doesn't matter which one. So we take one of these equations and we solve it for y, just like we've done before. So 3x plus y equals a negative 2. So this is our first equation. And we're going to solve it for y. It's very easy to do. We've got 3x over. And now we've got y equals minus 3x minus 2. And here's how we write our answer. I'm going to write just like our textbook writes it, the same way. We write our answer. It's a dependent equation, infinite number of solutions. And the first thing we come up with is our variable x, and how does that relate to your y? Okay, so we solved it for y here, so we use the variable x. Y was solved in terms of x, so it's a minus 3x minus 2. So what you do, if it comes out to have an infinite number of solutions, is you take one of the equations. Doesn't matter either one because they are the same. They are scalar multiples of each other. They're just exactly the same. They're the same. That's why they came out to be the same. So you take one of the equations, it doesn't matter which one, solve that equation for y. Okay. This becomes your y over here. And this is your x is your x. Right? And y goes here. And what that is saying is that it's saying every point on that line is a solution because they are the same line. So there's one of those in your homework. Yep, sorry about that. There we go. Is that down, you mean? Yeah. Okay, yep, sorry about that. Yep. So make sure we can see it here. Okay, so that's what we did. So the first thing we did was we took our two equations, okay, and we eliminated for x. Now you can eliminate for either variable. It doesn't matter. Just eliminate one of the variables, distribute it through the number. And once you get them to be exactly the same, 0 equaling 0. That is like an identity. We talked about identities way, way back in chapter 1. So that came out to be an identity. Once you figure out that they're an identity, you know that it has an infinite number of solutions. And these are what are called dependent equations. So then you take either equation and you solve it for y. Once you've solved it for y, that means you put the x variable here. And how does x relate to the y? Well, x relates to the y as a minus 3x minus 2. And then there's your answer. And that's what I'm looking for. An infinite number of solutions. And these are called dependent equations. And that's going to be your answer as the ordered pair. Okay, we've got just a few minutes here. And I think I'll briefly talk about how to use. I think we'll have enough time. Gauss-Jordan elimination. So we're going to pick a real easy one here just so we can do one. There's only one of these in your homework. And this is using a matrix to solve. And we're going to do one that's just like your homework. Page 553, we're going to look at question 36. And this will be the last question that we look at. So I'll go ahead and pass out the sign-in sheet. And copy this one down here. I've got the sign-in sheet around here somewhere. And this will be our last question here. Here's the sign-in sheet. And this one's going to be using what's called Gauss-Jordan and matrices. You can solve it with elimination. And you're basically going to be doing elimination anyways. It's just a different version of it. The matrices in this case will help us keep track of things. Now we've got a minus x plus y equals a minus 1. We've got y minus z equals 6. And we've got x plus z equals negative 1. Okay, so let's make sure we copy it down correctly. It's so easy to make a mistake here. Shouldn't take us too long to work this one out. And I only gave you one of these. And I tried to make it pretty easy for the elimination. So we're going to be using what's called Gauss-Jordan. So we're going to be using what's called Gauss-Jordan elimination. I'm going to rewrite this as a matrix. And a matrix is just basically a grid. It just helps us keep organized. So I'm going to rewrite this as our matrix here. 3 rows and 3 columns in the middle. And then this is our equal bar. So this is your x, your y, and your z. Now, all we need to do is plug in the numbers. And if we're missing a variable, we use a 0. So for our first equation, this is our first row here, second, third. Our first row, x. Well, x, nothing's in front, so we're going to use a minus 1. If there's no number, you put a 1 there. 1, 1, 1. So this is pretty easy to work with. We put the 1s there. So our x on our first one is a minus 1. We have a 1y, and do we have any z's? No, so we use a 0. And that's the minus 1 on the other side. Then the second equation, we have no x's, so that goes there as a 0. We have 1y, and we have a minus 1z, and that equals 6 there. And then finally, we have 1 we have no y's, and we have one z, and it equals a minus 1. Now what we want to do, we'll see if we can get this one finished. Hopefully we can. We should be able to, at least partly finished. We want to solve this and get our 3 answers. So x, y, and z. And so we're going to eliminate, we want to get zeros off our diagonals. So I'm going to take the first equation here, and I'm going to add it to the second. So we're going to take our first equation, we're going to add it to the second. So that's minus 1, 1, 0, and a negative 1. We're going to have a 0, 1, minus 1, 6. Now we're going to add here. Add and put it down below. So minus 1 plus 1, that makes it 0. That's what we want. We want as many zeros as possible. We want zeros here, and we want zeros here, and zeros here. Okay? 1 and 0 makes it 1, which is fine. 0 and 1 still makes it a 1. And minus 1 and 1, minus 1, that makes it a minus 2. Okay. Now, we've got part of it. We need to get more zeros. We want zeros on these diagonals. And what we want to do is we don't want to use the first equation because we have a 1 here. And if I start adding, it's going to mess those up. So then I look here at this 1. And I want zeros on this diagonal and this diagonal. So what I'm going to do is I'm going to take minus 1 times this row and add to the first row and add to the third row. Okay, so let's work on this one. And if we don't get it all finished, we'll finish it up next class period. I think we'll just do one more step because I think it's about time for class to be over. So we'll finish this one next time. So let's just multiply it by a minus 1, and then we'll add it to the top and add it to the bottom. So let's take this and multiply it by a minus 1 in the middle. Okay. Minus 1 times 0 is 0. Minus 1 times 1 is a minus 1. Minus 1 times minus 1 is 1. Minus 1 times 6 is a minus 6. Then we've got 0, 1, and 1, and a minus 2. Now, why I did this is now look what happens. If I add, what's going to happen here? Okay, if I take this one and I add up and down, what's going to happen? The middle is going to make 0. So let's do that. Okay, let's add those together and make zeros. We want zeros on these off diagonals. So minus 1, 0, 0. Those stay the same. Minus 1 and 1. Minus 1 and 1 makes it 0. Okay, 1 and 0 makes it 1. And the 1 stays the same. We've got a minus 6 here. We're adding up, so minus 6 and minus 1. Minus 6 minus 1 makes it a minus 7. And then we're going to be adding down. That makes it a 0 here. Okay, and 1 and 1 makes it 2. Minus 6 and minus 2 makes it a minus 8. We'll just have to finish this next time. I just don't quite have enough time to finish it. But we'll go ahead and finish this next time. Now, your homework is going to be 5.1, 5.2. So that first batch of that first page. I want you to do them all but question 10. Okay, we'll do question 10 next time. And we'll finish this one next class period. Yep, do you have a question? Okay, yep, thank you. Here. Okay, and if you've got any homework, pick that up. I do have old homework to pass back as well. So if you haven't picked up your homework in a while, I have it up here. Pick up your old homework. I will see everyone then on Thursday. And don't worry about 10. 10, we'll do 10 next time.